The last page of questions on constant proportionality. There is a final little challenge page on matching activity, which I may do a video for, but these are the last questions per se in the pack. So number 17, A is inversely proportional to the square of B. So this is very similar to the ones on the previous page, but inversely proportional. So A, fish, 1 over square of B, so B squared. I'm going to change that fish sign to an equals k. The k is going to take the place of the 1. So that's what we've got in terms of an equation so far. Now we're going to find that constant by substituting in these values. So 3 squared, which would be 9. So if we want to work out what k is, I'm going to times by 9. So k is 18. Okay, so my full equation is A equals 18 over B squared. Find the value of A when B is 2. So when B is 2, 2 squared will be 4. So A is equal to 4.5. Number 18. W is inversely proportional to the square root of B. So write that in equation. When B is 9, W is 9. I'll do it there. So the square root of 9 would be 3. So k is equal to 9 times 3, 27. So my formula is W equals 27 over square root of B. Work out the value of W when B is 4. So substituting in for 4, the square root of 4 would be 2. So half of 27 is 13.5. Work out the value of B when W is 1. So timesing by root B, and don't really need to divide by 1. So we get root B is equal to 27, and if we square both of those things, 27 squared is 729. Okay, question 19. Y is directly proportional to x squared. When x is 3, y is 36. Oh, I need to change put my equal sign in first. Okay. Three squared would be 9. So k is 4. So y equals 4x squared is the answer to A. Z is inversely proportional to x, and this is part B. We're talking about the same x here. So Z is inversely proportional to x when x is 4, z is 2. So first going to write that as an equation. Sub in. So k is 8. So going back to this one, z is equal to 8 now over x. So possibly shouldn't have used k this time around, because therefore I'm implying that this k is the same as this k. So if I change that, I know I've said that we always use k as the constant of proportionality, or we tend to, but actually we could use any letter really. It's just k seems to be the one we use the most. So I don't know, let's use another one. Let's call it M. I was going to go with L, but it look a bit too much like a 1. Okay. But anyway, it doesn't really matter. It's a constant and we found it, so now we can use a number instead. Now, show that z is equal to cy to the power of n, where c and n are numbers and c is greater than 0. You must find the values of c and n. So in other words, show the relationship between y and z. Don't involve x. So what we want to do here is write one of these formulae in terms of x. So start it by saying x equals, because then we can substitute it into the other formula to get rid of the x. So what should we go for here? Let's go for if we write this one in terms of x. So I'm going to bring this one down here. If I divide by 4, that will give me y over 4 is equal to x squared. And then I need to square root that, both sides of that, to get x. So x, and that will give me the square root of y, over 2, because when you square root a fraction, you can square root the top and square root the bottom separately. And then I'm going to substitute this in place of this x here. So that will give me z equals, go on computer, 8 over, instead of putting x, I'm going to put root y over 2. Now it's not nice to have a fraction within a fraction. So what we can do is bring this 2 up here to times by the numerator. If you think about dividing fractions, you're timesing by the reciprocal. So z is equal to 16 over square root of y. Now that doesn't look like that yet. Okay, how I could write that using a power rather than a square root sign, and also take into account that it's on the bottom of a fraction, is to write it as, this is not an easy question by the way, y to the power of negative 1/2. Okay, the negative made it on the bottom of the fraction there. The power of a half is the same as square rooting something. And that is the final answer. Okay, question 20. Oh, by the way, that question is probably sort of, you're up there with like grade 8, grade 9 kind of questions there. So don't worry too much if you couldn't do it. These graphs show 4 different proportionality relationships between y and x. Match them to their statement. Okay, so y is directly proportional to x. Well, if y is directly proportional to x, then y is equal to something times x. Oh, come on. Okay, and if you think about any graph where you've got y equals like 3x or y equals 2x, whatever, they make straight line graphs, okay, and varying this constant here just varies the steepness, but they're always a straight line graph, so that matches graph D. Y is inversely proportional to x, so it might be worth thinking of a few values of x, thinking of this equation, something over x, thinking what happens as you increase x, y will become smaller. Okay, if x was negative, okay, so getting more and more negative, y would also be negative, okay, but as it increases, this is getting smaller as well, so it matches this graph up here. Okay, we've seen reciprocal graphs, we've seen what graphs of the type y equals 1 over x look like, and they look like this. Y is proportional to the square of x, okay, so y equals something times x squared. Well, again, y equals x squared itself looks like this, okay, and when we increase that number in front of the x squared, the graph just kind of gets more narrow, okay, it stretches upwards if you like. So that is graph B. which means the leftover one is graph C. But if you want to think about it as well, y is inversely proportional to the square of x, so y equals something divided by the square of x. So it is a kind of reciprocal graph. But the effect of squaring x first means that even if we have a negative x value, okay, we won't get a negative y value, because when we square it, it will become positive. Okay, so that's the difference between those two. Okay guys, thanks for watching. I know this topic won't have made 100% sense probably so far, so keep practicing it. Do some of the Maths Watch questions perhaps, but you'll get there with it. It's just a process, okay? There might be some hard things in maths, but the hard things that are just processes are learnable. Alright, thanks guys.